So in the last video, we went over how to deal with complex numbers, the square root of negative numbers and and all that other fun stuff. Now we actually want to use that to solve the quadratic equations that we've been looking at. So for the sake of argument, suppose I have x squared plus x plus 7 equals 0. We know the setup, it's a quadratic, make sure it's set to 0, it is. Now I try to factor it, but clearly the only factors of 7 are 7 and 1, and I'm never going to get those factors to add up to 1. Which means it can't be factored, so I have to use the quadratic formula. So, negative b plus or minus the square root of b squared minus 4ac all over 2a. If I plug in here, that's negative 1 plus or minus the square root of 1 squared minus 4 times a, which is 1, times c, which is 7, all over 2 times 1. Now if I kind of simplify that out, that's negative 1 plus or minus the square root of 1 squared is 1, 4 times 7 is 28, so that's minus 28, all over 2. Now if I kind of keep going, that's negative 1 plus or minus the square root of 1 minus 28 is negative 27, all over 2. And the problem is, well, I have the square root of a negative. But now I know how to deal with that. I can rewrite this as negative 1 plus or minus the square root of 27 times I, all over 2. Now I've gotten rid of the negative, but it's a complex number, which means we have to put it in standard form, which just means I have to break this up as negative 1/2 plus or minus the square root of 27 over 2, I. And then if you're so inclined, you can simplify the square root of 27. The square root of 27 is the square root of 9 times the square root of 3. The square root of 9 is 3, so that's 3 root 3. So I can rewrite this as negative 1/2 plus or minus 3 root 3 over 2, I. And essentially it means now I can solve any quadratic equation that I've given. Set it equal to 0. If it can be factored, factor it, get the solutions that way using the zero product property. If it can't be factored, throw it into the quadratic formula. Sometimes, like in our other video going over these, we'll get some bizarre radical that's positive, and we just leave it in that form. Other times, we'll get negative square roots, but now with complex numbers, we know how to solve the negative square root. Just replace the negative with an I, and then simplify that and make sure it's in standard form. So really quickly, we'll just do one more to make sure we understand how to work through these. So, suppose we have 2x squared plus 4x plus 11 equals 0. I'm not even going to bother to try to factor this. We're just going to throw it into the quadratic formula. So I'll get negative b, which is 4, plus or minus the square root of 4 squared, which is 16, minus 4 times a, which is 2, times c, which is 11, all over 2 times 2. Which now gives me negative 4 plus or minus the square root of 16. 4 times 2 is 8, times 11 is 88. So 16 minus 88, all over 2 times 2, 4. Which then becomes negative 4 plus or minus the square root of 16 minus 88. That is negative 72, all over 4. And now, well, I have a negative, so I'll do my whole negative 4 over 4 plus or minus, pull out the negative, the square root of 72 over 4, I. And here I've already deliberately separated these because I know if I'm pulling the I out, it's a complex number, it's got to be in standard form. And now just reduce from there. Negative 4 over 4 is negative 1, plus or minus, here, again, I don't know the square root of 72, but that one I can simplify. 72 is 36 times 2, which means square root of 36 is 6, so that's 6 root 2. So this becomes 6 root 2 all over 4I. And then I can simplify from there. Negative 1 plus or minus the 6 and the 4 leaves me with 3 over 2 with the root 2 on top, I. And again, all this really means is now we can use the quadratic formula, we can get our solutions, and on the off chance we end up with a negative square root, I can now pull the negative out, write it as a complex number, and essentially solve every single quadratic equation that we'll possibly come up with.